So projection welding is our first topic. In projection welding, it is very similar with spot welding, but in spot welding, the spot is where the welding is get done between two electrodes. But when you need to join a bigger surface, then we make a projection. Suppose we want to join these two sheets in a lap joint. Now, if we just use our electrode in here and here and give pressure to it, then in between a joint will be formed, and they will first, because of the pressure, touch each other, and then they will be keep squeezed, and then joint will be formed in between surface of them. That will be the spot welding. But in projection welding, if we want to localize where the joint will be, so in such case we take the upper portion of the sheet and use a die and punch. Suppose we use a die like this and a punch like this. So this is called die and this is punch. So when punch provide pressure on this uh, plate or on this sheet of material, then what happens? The sheet bends like this way, so now this is the sheet which to be given on the top. So now this is simple spot welding. This is die punch. We apply pressure, and when we have applied pressure, the sheet produces projection. Now we take the lower part as it is, we keep on a backing strip or backing plate, okay, and over it we place the upper part which is bent here. Okay, so this is the upper sheet and this is the lower sheet. Now we attach electrode in here, or we provide electricity to this backing strip, and here we provide a pressure plate, and this is provided electricity. Suppose this is plus or this is minus. Okay, the this might be AC also. Okay, so the type of electric supply, whether it is AC or DC or polarity, does not matter much, because the current passed in a very small amount of time, very little amount of time, say 0.01 second, something like that, or 0.001 second, something like that, very small. Okay, now when this pressure plate gives pressure, and when it is squeezed and touched with the bottom plate here, upon providing electricity, the joint is produced here. So when we need to apply joint on a particular place, then we go for the projection welding. Suppose you have a sheet like this and you need to join it with this one. So then what we do, we apply pressure here and here. Okay, as a result, two projections are made, Okay, these two projections are made by help of die and punch. Now, after that, there is a projection, there is a projection. Now, if we apply these two sheets, then we use a pressure plate here and we apply electricity, and thus as a result when the pressure plate is ready to apply pressure, then it provides the downward force which you know pressures this upper plate on the lower plate. So as a result, the joint will be produced like this. So here the joint will be produced and here the joint will be produced. So these projections are actually initiating the joints. These two projections are making sure that the joint locations will be here and here. Okay, so first initially projection has been made. So is the procedure clear to you?
Yes, sir.
Okay, first we prepare projection and then we apply current so that the spot welding happens on that projected points. So what is the need of doing this thing? Why do you need to apply these uh, projection on the plates? So whenever the material is galvanized or coated, in such cases the material which are difficult to joint, in such cases this type of welding is done. So materials jointed are mainly galvanized steel. If the surface of the steel is galvanized, then it is very difficult to weld because of the coating. So in such case, if we do the projection on the surface, then the coating gets off, and as a result this type of projection welding becomes easier. But doing spot welding on galvanized steel is very difficult because of the coating. Now then, tin plates, stainless steels, titanium alloys, naval brass, brass which are used in naval applications. In such cases, we use this method, and also low carbon steels. So the applications are basically attaching small fastens, nuts, special bolts, and similar parts to large component. Suppose there is a very large component, and with it you need to attach a very small component. So in such case, that large component which is made of sheet is mostly projected, and then current is passed while the pressure is applied on that smaller objects. So when you need to attach a nut with a sheet, in such case these projections weldings are done. Nuts, bolts, when you attach with a bigger plate or a bigger sheet. Basically, the projection welding is localizing the heat of welding in a certain place where it needed. Now, the advantages of projection welding are: a large number of joint, large and finite number of joints are produced at a time. Second, scaled, rusted, oil, metal coated, all materials can be joined easily, because whenever the projection is done by help of the punch, the top of that uh, bent, this this portion becomes rust free because of the pressure. So that's why it becomes very easy. You do not need to uh, scratch out the rust, you do not need to clear the oil, you do not need to clear the paint, which is very helpful and very faster in industry operations. And this requires less pressure, less amount of current, and then this projection welding locates the weld in desired points. Suppose there is a very weak portion and you do not want to join that weak portion. So in such case, it helps. You can join in a stronger portion just beside it. These electrodes possesses longer life, and it is a very faster process, as several joint can be made in a just fraction of second. But it has some limitations too. Limitations of projection welding is, the first limitation is thick sheets are difficult to weld. Number two, the metals, those are not stronger enough to support projections, they cannot be welded. If sheets cannot withstand projection pressure, then it cannot be welded. Number three, for same length of joint, all of the projections should be of same height. All of the projections should be of same height. And number four, very difficult to weld dissimilar materials. Okay, any question on this, on projection welding? No questions. Okay, so let us start on the new topic. Next topic is flash bar welding. In flash bar welding, from the name you can understand this is required on bar joint. So this is also a resistance welding, type of resistance welding, and the end of the stocks are clamped with a slight separation, and as a result, let me draw the figure. We hold these uh, uh, two bars or tubes in very straight position, in straight alignment, with using of strong holding mechanism. Now, with help of clamps, suppose these are two clamps, strong clamps. Now these two clamps are providing electricity. These two clamps are provided electricity. Okay, as a result, what happens? This one clamp is fixed and second clamp is moving. And when the electricity passes, this moving clamp moves towards the fixed clamp very slowly, and thus this gap reduces very slowly. So when they have gap about 2-3 millimeter, then the jump start of the electron starts, and as a result, a flashing occurs because of very less distance between these two clamps. Flashing occurs instead of stable arc. Because of the reducing distance, flashing occurs, and these two ends uh, get softened up, becomes red hot and gets softened up, and uh, enters into plasma state or semi-liquid state. uh, then the electricity stopped and they are pressed together, and as a result we get this type of joint. So here a raised portion is seen, which can be called as bar. We already know the term what is called bar. So here, because of the flash at the end, this joint is made. Now this process produces a homogeneous joint. The joint is homogeneous, and this is without addition of filler material. So if we write out its characteristics, uh, it seems the joint is homogeneous joint. Joint occurs without any filler material, and flashing occurs. and most of the cases these are either semi-automatic or automatic. Otherwise flashing could not be controlled and short circuit will occur. Now one clamp is fixed, other is moving. This movement might be mechanical with a lever or hand wheels, or hydraulical, or pneumatic. If the these tubes or these bars are very heavy, then you need either mechanical or pneumatic controls. Now high voltage, high current is required to establish the flashing. Okay, the materials is tool steel, stainless steel, aluminium, and its alloys, copper alloys, and etc. This can be jointed by this method. Now the advantages are lot of dissimilar materials can be joined. Strength factors might be 100% of might be 100% comparing the parent metals. Next one is no edge preparation is required because of the high voltage. If there is an impurities or rust, they get automatically cleared. Next, it is faster process, cost of joint is low because you just fix them in these two clamps and the rest of the process will be automatical. So the cost, no filler material is required. That's why cost is low. Operating cost is low. Current consumption is low also. And because of these two strong rigid clamps, the alignment is maintained with high accuracy. Yes, I said high current is required. High voltage, high current. Both are required high here. Okay. Now it has limitations too, because the current consumption is low, because the time of the current passing is very low, just fraction of seconds, very faster process. That's why the current value is high, but the transferred charge are low. What I am trying to say is the voltage required is high, the current required is also high, the power is high. That means that energy transfer in unit time, that is high. But if the time is less, then the total energy transferred is less. That's why the cost is less. And the cost is compared with the other procedures. It is a comparable processes. And the last point of advantages is alignment is maintained with high accuracy. That means if these two uh, lengthy tubes are joined, when they are made straight, so after the joint, the straightness is achieved. Okay. If you go for manual weldings, you are welcome. If you go for manual weldings, the straightness cannot be maintained properly. But here, because there are rigid and fixed clamps to hold these two parts, that's why the straightness can be achieved. Now we will discuss the limitations of flash butt welding. Some metal is lost due to flashing and upsetting. The straightness is difficult to maintain, because if any uh, very minimum amount of force is given externally, or if the maintenance of the machine is not taken properly, if the clamps have little looseness, then it becomes very difficult. So you will get somehow straight, but not very accurate. That's the problem, to get accuracy. Next, the operator need protection. Protection from flying particles while flashing occurs, as the process is a fire hazard. When the flashing is done, fire spreads out in terms of flying particles, just like you have seen in grinding, which are very uh, less harmful. But in this case, it is containing much more danger. Okay. Cast iron, brittle materials like cast iron, there are some material like lead and alloys, I mean, uh, alloys of leads. These things cannot be welded. Next, the opening of the clamps of jaws limits the size of workpiece. Now, the process is suitable only on bar joints and very heavy shapes cannot be held and thus cannot be welded. It has several applications. The materials that can be forged can be also flash melted. This is a general rule. So materials that can be forged can be also flash welded. Now there are some materials which can be welded properly with some precautions. Those are low carbon steel. Number two, low alloy steel. Number three, tool steel. Number four, stainless steel. Copper alloys. Aluminum alloys. Nickel alloys. Molybdenum alloys. Magnesium alloys. And titanium alloys. But this is, you have to remember, this is unsuitable for lead and its alloys. Antimony, zinc, bismuth, and all of their alloys. So These are normally used in automobile industry, welding of tubular and solid structure, assemblies, aircraft industry, bandsaw blade, drills, welding of drills, reamers, taps, mild steel or its alloys, welding of pipes and similar type jobs. There are lots of uses that depends on the availability of the system and depends on the respective decision maker or engineer. Okay, so today we'll stop here. We have very few portion left in resistance welding, and then we will advance on the other welding processes. Okay, any question on today's class?
Sir, we